All right, man, that is probably the coolest fractal video that I've seen today, or at least in the last 5 minutes. Yeah, that's pretty awesome. So you're probably thinking, what do fractals have to do? That's a fractal. This is a famous one. This is the Mandelbrot set. You can see it over here. Essentially, it's the same general shape repeating itself infinitely. Super cool idea here that if you take a look at the perimeter, you know, this is a pretty finite area. I've got it in a box here. But if you look at the perimeter, it's made up of all those little bug-looking shapes or whatever. It's got an infinite perimeter. If you try to add up the perimeter of this thing, it's infinite in a finite space. Pretty cool idea there. How does that come about? It comes about from complex numbers. Remember A plus BI from the last section? We actually, you can use that to make these cool different fractals, but we have to know operations. We have to know how to add, subtract, multiply, and divide with them. So the Mandelbrot set, you know, if C stands for A plus BI, that C is some complex number. You take it and you do these different iterations where you take a point and you plug it in. So the Mandelbrot set is actually a quadratic. You plug it in over here, you square it, you add its original, you get a new point, plug that back in, and you keep this cycle going where you keep plug it in, plug it in, plug it in, and it jumps these points around everywhere, makes these cool different shapes and whatnot. So it's kind of like this idea of chaos theory. Where is it going to end up? Pretty crazy. I love it. So we're going to learn some operations of this, and we're going to look at fractals that I think are kind of cool along the way. Here's some famous ones down here at the bottom. We got Sierpinski's triangle. Again, you've got an infinite amount of triangles in this finite space. You know, here they are getting smaller, smaller, smaller. I like this one, the hands, and of course the real life. Look at that hair. That is awesome. So cool. So let's add and subtract these things. How do you add and subtract complex numbers? No problem. You just take the real part. You add the real number. So 4 plus 7 is 11. And you do what with the imaginary part? You do the same thing. You add the imaginary part. So negative 3 plus 9 is positive 6. So just be careful with your signs here. What I like to do when I'm subtracting here is go ahead and distribute that negative. This is, you're subtracting both of those. So what I would do is just distribute like a negative 1. So it changes the sign there. Once you do that, then no problems with the signs. It's the same thing that we're doing with adding. You say 5 minus 3 is 2, and then you can say negative 2i minus 7i is a negative 9i. So we're getting these complex points again. Remember, the complex points, the real part plus the imaginary part. Awesome. Would this freak you out if I did this? This is all imaginary here, but if you wanted to, you could write the real part. It's 0 plus 4i. Just add them. 0 plus the 5 is the 5. Add your imaginaries. We've got 4i minus 12i is minus 8i. So don't freak out if it's not written there. We don't have to write it. In fact, we're not going to write it. Just add the imaginary to the imaginary part. So it's kind of like combining like terms. Super cool. So we're done with add and subtract. Let's multiply. So this one gets a little bit trickier, but it's this is a good one. We're going to use a lot of these. And again, I threw a different little version of that Mandelbrot set down there. Pretty cool. Let's distribute. Can you distribute a real number? Sure, no problem. It's just normal distribution. 4 times 3 is 12. 4 times 5i is 20i. Not a problem. What if I make it an imaginary number? Again, I like it. Just follows all the same rules. 2i times 3 is 6i. 2i times 7i is 14. What's I times I is I squared. So again, this is where it gets a little bit trickier. Remember, what is I squared? That was kind of the whole key of last lesson. What is the whole point of I squared? Why do we have these imaginary numbers? Well, I squared actually equals negative 1. That was the whole idea of we can do the square roots of negative. So we actually have to replace it now. So 14i squared is really, that I squared becomes negative 1, so this becomes 6i minus 14. And a lot of times we put it in the standard form where we put the real part first, so it's negative 14 plus 6i. So that's the key from last time, that I squared is really negative I. So when you distribute it, you get this nice back in standard form again. A plus bi, that standard form right there. Cool. Can you do binomial times a binomial? Or some people like to call this FOIL. I prefer to call it distribute. I'm going to distribute this to this and this, so 3 times 3 is 9. Distribute the 3 to the 7 is 21i. And then I'm going to distribute the negative 2i. It takes a sign in front, so this becomes minus 6i. And distribute that to this is minus 14. And again, I, Captain, or something that's crazy. I is I squared, so I've got this. Let's combine some like terms here. 21i minus 6i is what? 15i? And then again, what do I do with that I squared? It really becomes -1. So you got to put that in there. So we're really looking at 9 plus 15i plus 14. Add those together, we're looking at 23 plus 15i. So our goal is that standard form, a plus bi, complex number. Boom, there it is. Love it. We have done multiplication. So we've add, subtract, multiply, and divide. Oh, this is a cool one. This is the Julia set in here. So a different little variation of the Mandelbrot set. Pretty cool. Try these, pause it, make sure you can get these. I'm going to post the answers, and then we'll see how you did. Good luck. All right, here they are right here. So hopefully your answers match up. Just be careful with that I squared down here and over here that you're making -1, and it simplifies down to those. Awesome. Moving on. Let's check out division here. Oh my goodness, what is that down there? A bean fractal. Holy cow. That kind of freaks me out. I got to focus here. That's a lot of beans right there. Dividing can get a little bit trickier here. Let's take a basic division one though over here. So let's start with this guy over here. This is like splitting a fraction here. The whole thing's being divided by 3, so we've done this in the past. You can really say it's just 4 divided by 3 over 3i divided by 3. So we can split that fraction apart. Sometimes it reduces a little bit more. 4/3 is cool, but what's 3 over 3? It's just 1, so that's just 1i. Or really, I'm going to write 4/3 minus i there. So not a problem here. Just split the fraction, and again, I'm in standard form. Reduce that. That's going to come in handy, especially next section, next couple sections actually. How do we do, how's it look when we're trying to solve an equation? So I put this under divide because we're going to solve some equations. So remember, if we get it down to just the square here, we're going to take the square root of both sides. So this is a little bit from last time. So we've got 2x plus 1 equals the square root of -9. Remember, if you introduce the square root, it's plus or minus. It could be the positive or negative version of that. Then what do we do here? Well, let's break down what is the square root of that. Well, the square root of 9 is 3, and it's -9, so what happens here? We're looking at plus or minus 3i. I'm going to go ahead and delete Mr. Bean Fractal here because that's kind of creeping me out. Can we get him out of here? And we need the space. So we've gotten that far. What do we do here? We're going to subtract 1 from both sides, so those cancel. So we're looking at 12x equals that -1 plus or minus 3i. So that was actually last section. You passed the match check. You're good to go on that. Here's the new step. This division at the end, we're going to divide everything by 2. So as you can see from the last example, we are going to use this. So I'm not just making it up here. We're looking at, break this in half. We're looking at -1/2 plus or minus 3/2 i. And you can put that i on top. I like to put it as a fraction, but we are going to break these down. Doesn't simplify. We're good to go there. Pretty cool, huh? I thought you'd like that. Can we get a little bit harder here? Sure. I got to get the perfect square by itself, so I'm going to do something like this. So I'm really looking at 3y minus 1 squared equals -27. Now that I got it by itself, let's go ahead and square root both sides. So that was the goal. Those cancel each other out. Okay, so we square root, so they cancel each other out, so we're left with 3y over here. And again, we're going to take the square root of this, so it's a plus or minus. We introduced that. What is the square root of 27? Well, really, it's I radical 27. So we're going to go ahead and say, sure, if I can square I radical 27, I'm going to get the square root of -27. So that's the whole idea of that. So can we solve this? Sure. Let's move on from this bad boy. What do I got to do next? Well, maybe we'll leave that 27 alone for now. I'm going to add 1 to both sides. So those cancel. So I've got 3y equals, add that 1, plus or minus I radical 27. And then this new step, we're adding this big division step where it cancels that out. We're looking at y equals, let's go ahead and split this bad boy up. We've got 1/3 plus or minus the square root of 27 all over 3. And that's times I. So that's pretty good. That's a good answer, but that would never match like the back of the book or something because it's not simplified. So let's simplify this. The key is, what happens to that square root of 27? It breaks down, yeah? It breaks down into what? Radical 9 times radical 3 all over 3i. And what is the square root? Why did I pick 9 and 3? Well, because the square root of 9 is 3. So check that out. I can rewrite that. Radical 27 turns into 3 radical 3, and check that out, that cancels. Aha! So really a lot of simplifying going on to get to our final answer here as 1/3 plus or minus. We're left with, remember, the I goes in front when it's just a radical because we don't want it back there in the square root because it gets weird. Is it in there? Is it out of there? We don't know. Check that out. That is the final simplified answer. So a lot of simplifying on these. I love it. It's a lot of fun. I think you're going to enjoy that. All right, last thing we're going to do, I feel like I'm cruising. You may have to pause me, slow me down. I'm on a roll here. We got these conjugates. So what does this mean by conjugates? Well, this isn't in standard form, so we're going to get it in standard form here. Oh, let's talk about the fractal. We can't pass this fractal up. Probably my favorite fractal to eat. Yeah, that's right, Broccaflower. Check that out. Infinite little spirals in there. Pretty cool. Especially if you like that kind of stuff. So what does this mean? Sometimes the idea of this, I don't like this I in the bottom. If you remember back to like almost like square roots where it's hard to work with it. So how do I get rid of I in the bottom? Well, I'm going to multiply it by I. So to get rid of I, we're just going to multiply it in this case by I. So I'm going to multiply it by I. But whatever you do to the bottom fraction, what do you got to do? You got to do it to the top. So this is a very special one. I over I is just 1. You know, anything over itself is 1. So I'm not changing this problem at all. I'm multiplying by 1. It's just a special one. You're probably thinking, why in the world did he pick I? Well, check this out. What is 2I times I? That is 2I squared. Ooh, that's pretty cool. But remember, on top you got to distribute. This is the whole top, so you actually have to distribute that I. So we're actually looking at 4I minus 3I squared. Maybe you can see why I picked that I. You know, maybe it's not natural at first, but maybe you see it now. What is I squared? Aha, it's -1. So we've really eliminated that I off the bottom, which is pretty great. And also, it kind of changed the top too, didn't we? This I squared becomes -1. So our final answer here on top, we're looking at -3 times -1 is +3 plus 4I. And then what happens on bottom? We've got this -2. And it's cool if you want to leave that negative on bottom. Whoa, we're not done yet. Sorry, I got a little ahead of myself here. Is that standard form? No, it's not standard form, so we actually got to split it up. Let's split that bad boy up. So we're really looking at 3 over -2, plus 4 over -2I. So be real careful with your signs here. You know, if the negatives on bottom or top, it doesn't matter. That's just a -3/2. But be careful here. This is a minus, 2I right here, because it's a positive and a negative. So make sure you're subtracting there. It's kind of weird to go plus a minus. So that is actually the standard form answer of that. That is now simplified. Yay, we got it right there. We are good to go. Awesome. So that was not too bad when it's just an I. If you want to get rid of I on bottom, just multiply it by I. Problem is here, though, this one's trickier. This is where we're going to get into the conjugate. We can't multiply by I here because we'd have 3I. That's a bummer. So we're going to multiply by its conjugate. All that means is write the same exact thing, just change the sign. So we're going to change the sign. This becomes a difference of squares, which is awesome, and that's why it's going to get rid of our i's. But whatever you do to the bottom, remember, you got to do it to the top to keep it equal. So again, I'm multiplying by 1. This nasty fraction over this, the same thing on bottom, is just 1 if I reduce it. So I'm going to multiply this out. Let's do it. Let's see what happens here. On bottom, I'm going to go 3 times 3 is 9. Then I'm going to go what? Minus 6i. I'm multiplying these out. Plus 6i. That's where the magic happens. And minus 4i squared. So that's the whole bottom. I love it. On top, again, we're going to do this idea. Some people call it FOIL. I just call it distribute. So we're going to say 12 minus 8i. Then I'm going to distribute the 3. We've got minus 9i. And then a negative times a negative gives us that plus 6i squared. So these look pretty nasty, but it's not bad. Just stick with it. You'll be okay. Can we simplify this a little bit? Sure. On bottom, this is the reason I picked this difference of squares or its conjugate is because these cancel. Minus 6i plus 6i. So that's really, really good. So the bottom is going to be 9 minus, and remember that I squared is -1. So I'm going to bring that all down here. On top, let's combine like terms. The middle terms, we can combine them together. So we're looking at what? We're looking at 12. And then we've got what? Negative 17i's. And then 6i squared. Remember, that's the whole idea of that -1 in there. So again, some more simplification going on here. On top, 12, and that'll become a -6, so that'll be 6 minus 17i. What's going to happen on bottom? Well, we've got -4 times -1. That's positive, so we're looking at 13. Is that bad boy in standard form? No. Let's split it up. So we've got 6 over 13 minus 17 over 13 over I. That is a pretty looking answer right there. Boom. So that original thing right here with the I in the bottom, we got rid of the I in the bottom. Not only that, we wrote it in standard form, so it's much nicer to deal with. Now we can add them, subtract them, multiply them, all that fun stuff. So we're going to multiply by the conjugate. We're just going to change the sign and multiply it. Makes a nice difference of squares. Love it. Ooh, a little lightning here at the end. So lightning looks like a fractal. In fact, there's one to represent it. Pretty cool. Try these. See how you do. We got a little solving equations, and then getting rid of that I in the bottom. Putting these in standard form on bottom. Pause it. Try it. Good luck. All right, here are my answers. Check them out. They're all in blue. I hope they match your answers. If they aren't matching your answers, check out my work. Make sure, find your steps, see what happened. I showed a lot of work here. You may notice something if you do enough of these conjugates at the end. For the bottom, it works out kind of cool. I'm going to give you this little tip here. Maybe if you realized it. Check this out. Remember my A here was 5. My B in this was -2, and the sign doesn't matter so much here. But what is this bottom number here? Well, check this out. It is 5 squared and 2 squared. 25 and 4 is 29. That's a little trick there. Because it's different squares than the I squared here, that's always going to happen, so that can save you a little time if you're into that. If not, just multiply it out. If you enjoy multiplying out, you're good to go. All right, I'm going to end you with, I feel sometimes I make fun of the other algebros, and I enjoy doing that. But, Mr. Sullivan, he's been talking about charities and all these different things. I'm like, man, he's taking the high road here. Can't make fun, what are you going to do about that? Can't make fun of that. So here's just something super cool. Kind of looks like fractals in this water drawing here, and plus it's an ad for a good cause here. So I hope you enjoy this, and good luck on the master check. Peace out.
Water may seem harmless, colorless, odorless, transparent. Water may seem harmless, but it kills millions of people every year all around the world. Just like that. Silently. Quietly. When only a little bit of ink can reveal this terrible truth.